Hello friends, welcome to H2 Academy. In the last lecture we have discussed up to question number 5. So we will discuss question number 6 onwards in this particular lecture. So basically we are discussing the problems on the stable and unstable equilibrium. So what we have seen in the previous set of lecture is that the basic condition for the stable and unstable equilibrium is for the stable equilibrium the condition is 1 upon rho 1 plus 1 upon rho 2 is less than 1 upon h, and for unstable equilibrium the condition is 1 upon rho 1 plus 1 upon rho 2 is greater than 1 upon h. Okay, so rho 1 is the radius of curvature of the upper body. So let us consider two bodies. This is body 1 and this is body 2. So rho 1 is the radius of curvature of the upper body, rho 2 is the radius of curvature of the lower body, and h is the distance of center of gravity from the line of surface of contact. Okay, so this we have discussed in detail in the previous set of lectures. So let us start discussing the questions. So we have a lamina in the form of an isosceles triangle whose vertical angle is alpha is placed on a sphere of radius r. So let us draw a sphere. So we have a sphere like this of radius r. Okay, let us draw it here. So we have a sphere like this, and there is an isosceles triangle whose vertical angle is alpha is placed on a sphere of radius r so that its plane is vertical and one of the equal side is in contact with the sphere. So let us draw the triangle. Let us draw the triangle. Okay, so these two sides are equal. Okay, so these two sides are equal and the vertical angle is alpha, so half of the angle will be alpha by 2 and this is alpha by 2. Okay, and since this is a straight line, so the radius of curvature of this is actually this is upper body, this is lower body, and this is the line of surface of contact. Okay, let us name this. This is A, this is B, this is C, and this is D. Okay, so this is the upper body and this is the lower body, and this is the line of surface of contact. Okay, so we have for the upper body the radius of curvature is rho 1, that is infinity, and for lower body the sphere is of radius r, and for lower body the radius of curvature is rho 2 is equal to r. Okay, and we have the condition for the stable equilibrium is 1 upon rho 1 plus 1 upon rho 2 is less than 1 upon h, and h is the distance of center of gravity from the line of surface of contact. So the center of gravity for this isosceles triangle will lie here, somewhere here, at the distance of, so this distance will be this AD upon 3. This is AD upon 3. Okay, so we have, and the where A is one of the equal sides of the triangle, so this distance is A and this distance is also A. Okay, so what will be the value of AD? So AD is equal to A cos alpha by 2. AD is equal to A cos alpha by 2. So let us name this as G, this point as G. G is the position of center of gravity of this isosceles triangle. Okay, so now we have the value of AG will be, is equal to 2 by 3 times of this is AD by 3, so this value will be 2 by 3 times of AD, and the value of AD is A cos alpha by 2. So this is equal to 2 by 3 into a cos alpha by 2. Okay, so we have the value of AG is equal to 2a by 3 cos alpha by 2. This is the value of AG. Okay, so what will be this distance? So this is actually h, this is g, so this distance is h. So in this particular triangle, let us look in this particular triangle. Okay, and let us name this as E, point E. So we have the triangle as, this is the triangle, this point is G, and this point is E, and this is H, and this is alpha by 2, and this is point A. Okay, so H will be AG sin alpha by 2. So value of H is AG sin alpha by 2. So let us place the value of AG here. Okay. So we have the value of H as H is equal to AG sin alpha by 2. So the value of H is equal to, value of AG is 2a by 3 cos alpha by 2 sin alpha by 2. Okay, so H is equal to a upon 3 times of 2 sin alpha by 2 cos alpha by 2. So H is equal to a by 3 sin alpha. Okay, so now let us put the values in the expression for the, let us put the values in the equation for the stable equilibrium. So we have the equation as 1 upon rho 1 plus 1 upon rho 2 is less than 1 upon h. So from here we have rho 1 is infinity because this line is a straight line. Okay, so we have this as because the surface of contact, this body, this line is a straight line. So we have the rho 1 is infinity. So we have this as infinity plus 1 upon rho 2. The value of rho 2 is r, is less than 1 upon h. So h is less than r. So this value is less than r. Okay, so we have a by 3 sin alpha is less than r. So from here we have what we have to show, sin alpha is less than, sin alpha is less than 3r upon a. So this we have to show in the question. Okay, now let us discuss question number 7. Okay, so we have to, in the question number 6 we have to discuss, we have to show sin alpha is less than 3r upon a. Okay, so now let us discuss question number 7. Let us discuss question number 7. A uniform hemisphere rests in equilibrium with its base upwards on the top of a sphere of double its radius. So that the greatest weight that can be placed at the center of the plane face without rendering the equilibrium unstable is 1/8 the weight of the hemisphere. Okay, so we have a sphere of double its radius, that is double of the radius of hemisphere. So let us draw the diagram first. So we have a sphere like this, and there is a hemisphere. So radius of this is r, and radius of a sphere will be 2r. Okay, so that the greatest weight that can be placed at the center of the plane face. Let us take the greatest weight as, let us take the weight that is placed at the center of this plane face is small w, is 1/8 the weight of the hemisphere, and let us take the weight of this hemisphere as capital W. Okay, and we have the radius of curvature of this. So we have the line of surface of contact is this one, this is the line of surface of contact. So the radius of curvature of the upper body will be r. So rho 1 is equal to r, and for the lower body we have rho 2 is equal to 2r. Okay, and we have, and let us take G as the combined center of gravity of this whole system. Let us take this point as G. Okay, and we have the center of gravity of this hemisphere from this particular point, from this particular line, is 5r upon 8. This is, it is somewhere here. So this distance is 5r upon 8. Okay, so let us find the value of this point G, that is OG. Okay, and this distance is OG is small h. Okay, so in the condition for the stable equilibrium, we have 1 upon rho 1 plus 1 upon rho 2 is less than 1 upon h. So this h is this OG. G is the point of center of gravity of this whole system. Okay, so we have the value of OG, h is equal to OG is equal to, okay, this is small w times of, and the position of the center of gravity of this weight w is at a distance of r. So this is OG into, and let us take this point as f. Okay, so w into OF plus capital W into the position of center of gravity of this hemisphere is at a distance of 5r upon 8. 5r upon 8 upon a small w plus capital W, and the value of OF is r. Let us place this here. Okay, so the condition here is that, let us place the values here. So this is 1 upon rho 1, so this is 1 upon r plus rho 2 is 2r. 1 upon 2r is less than 1 upon h. So from here we have 3 upon 2r is less than 1 upon h. So from here h is less than 2r upon 3. Okay, 3 upon 2r upon 3, h is less than 2r upon 3. So this is less than, so from here we have, so the condition, let us put this in this particular condition. So we have 1 upon r plus rho 2 is 2r. 1 upon 2r is less than 1 upon h. So this is 3 upon 2r is less than 1 upon h. So from here h is less than 2r upon 3. Okay, so and the value of h is this one. So w plus 5 capital W upon 8 into r upon small w plus capital W is less than 2r upon 3. So r gets cancelled. So let us further simplify this. So from here we have 3w, 3 small w plus, this is 15 capital W upon 8 is less than, this is 2 small w plus 2 capital W. Okay, so from here we have, let us take this here, sorry, so this is a small w and this is a small w. Let us subtract this with 3w. So this is w is less than 2 capital W minus 15 capital W upon 8. Okay, so small w is less than, this is capital W upon 8. Okay, so this small w is the weight that is placed, at center of plane face, and capital W is weight of hemisphere. Okay, so we have discussed up to question number 7. So further questions you can watch our playlist section, that is most probable questions on statics. Okay, thank you.